Hey everyone, I am Nancy Agrawal and welcome back to my YouTube channel. Now we are going to solve the third question of Leetcode Biweekly Contest 149, which is reschedule meetings for maximum free time second. So the second question was reschedule meeting for maximum free time first. You should also go and watch first this video so that you must have an understanding like what is this question going to about. Okay, so let's see what is this question. So in this question, you are given an integer event time denoting the duration of an event, and you are also given two integer arrays start time and end time, each of length n, as similar to the previous question. And these represent the start and end time of n overlapping meetings that occur during the event between time 0 and event time, where the ith meeting occurs during the time this. And this information is same as the previous question, and you can reschedule at most one meeting. In the previous question we were given k meetings, but here the k is 1 always. And while moving its start time while maintaining the same duration such that the meetings remain non-overlapping to maximize the longest continuous period of free time during the event. In the previous question also we were asked the longest continuous period of free time when we can move at most k meetings, but here we can move at most one meeting only. And we need to return the maximum amount of free time possible after rearranging the meetings. But here meetings, it is a valid for the relative order of the meetings to change after rescheduling one meeting. In this question we can change the relative order of meetings. In the previous one we cannot change the relative order of meetings. We can only slide the meetings. We cannot change their orders. But in this question we can also change the relative order of the meetings. And the meeting cannot be rescheduled to a time outside the event, and they should remain non-overlapping. Okay. So it is little bit similar to the previous one. So I would suggest that you should go first and then watch that video first and then come to this video. The approach for this question is going to be different, but it would be better if you watch that video first. Okay, so let's see the examples. So in this example, we have been given that event time is 5. One meeting starts from 1 and end at 2, and another start at 3 and end at 5. So in this what we can do? We can't pick this meeting, put here, we can't pick this meeting, put here. So in this example, we can't change the relative order of meetings in any way, because this meeting is of length 2 and there is no space for length 2, and this meeting is of length 1 and there is no space of length 1. So in this example, there is nothing new, it is just like the previous one only. So let's see some other example. So in this example, you have been given an event time of 10, where one meeting starts at 0, end at 1, another starts at 7, end at 8, another starts at 9 and end at 10. So what are all the possible ways for this event? So either we can move this meeting to here or this meeting to here, right? We cannot put this meeting here as there is no space, and neither here as there is also no space, right? Okay, and what else we can do? Or we can take and put this meeting here, right? If we put this meeting here, then the longest duration available is 7, right? Or if we don't put this meeting here, if we just move this meeting here, then the longest length available is 8 minus 1, that is also 7. So both the ways are possible, and the maximum of both of them is also the 7, as you can see here. So what is different in this question is that we can pick a meeting and put it somewhere else if the gap is greater than or equals to the duration of that meeting, right? Okay, so let's see first. Let's suppose we have gap 1, meeting 1, gap 2, meeting 2, gap 3, meeting 3, and gap 4, right? So what we can do, there are two cases. Either we can slide a meeting, or we can pick and place a meeting to some other place, and in this case the relative order of meetings will get changed. Okay, so first see this situation, pick and place. So when we pick M2, either we can place it here or either we can place it in the right position, right? Either we can place it in any of the gaps in the right or in any of the gaps in the left, considering G1 is greater than is equals to the length of the M2, right? Okay, so this is one condition. And the another condition is that either we can just slide this M2 to G2 or slide this M2 to G3, right? So there can be only two cases and we just need to cover these two cases to solve this question. So what we can do is, for the case of pick and place, when we want to pick and place it to the left or right, so what we need to do is, first we need to store the left max and the right max, right? Why? Because we need to know that whether which is the longest gap available, and we need to check this condition if we can put our meeting in that gap or not. Okay, so let's see how we will create this left max and right max. Okay, so let's say this is our one example in which I have marked the duration of meetings as well. So the gaps here are, let's say this is 1, this is also gap 2 1, and gap 3 is also 1, gap 4 is also 1, and gap 5 is 4. Cool. Now how we will get the suffix? So for the last meeting, this one, this is the case of sliding, right? This is the area in which we can slide this meeting. We don't need to cover this place in the pick and place. So there is no one here at the right max for the last meeting, because what we were doing here is that the right max will be calculated after a particular meeting. If any gap occurs after a meeting, if we talk about this meeting, then how we will calculate the right max for this meeting? There is one gap and there is one meeting, and after that meeting, if there is any gap, then that will be considered in the right max for this M2 meeting. So for the last meeting, there is no right max. Okay, and for this meeting, the right max will be this, the maximum of both of these, which is 4. And for this meeting, for this M3 meeting, the gap will be maximum of 4 and 1. This will be also 4, this will be also 4, and this will be also 4, right? Okay, now how will we calculate the prefix? Let's say for this meeting M3, just a second, yeah. So if we talk about this meeting M3, this is the left portion and this is the right portion. So for the prefix, let's consider this G4. Let's say if this is at index I, then this will be I minus 1 and this will be I minus 2, right? So for this particular gap G4, whether this G3 will be considered in its left max? No, because this will get considered in the sliding portion. We can slide this meeting in this portion. So for considering the left max, we will need to take the gap before that, which is I minus 2. So this is a tricky point in while calculating the prefix one. So for the first, there will be no prefix. For the second also, like G2, G1 will not be considered in prefix, so we can also mark it as no. And for G3, now G1 will be considered in prefix, right? So what we will take? Maximum of this prefix minus 1 and gaps of I minus 2. So this will be 1, and for this also take the maximum of this and this will be 1. Now for this, take the maximum of this and this, then this will be 1. So this point is little bit tricky while calculating the prefix. So let me also show you the corresponding code snippet to the left max and right max, so that you will not get confused later on. So here we are calculating the left max and right max. So what we have done in left max? The maximum of left max of I minus 1 and free time of I minus 2, And right maximum, what we have done? Right max of I plus 1 and free time of I plus 1. Okay, there's just a tricky point of I minus 2 while calculating the left max, because you can see from this example, like while calculating for G4, G3 will not be considered in left max because that will get considered while sliding. So we will consider the gap at index I minus 2. Okay, now what we need to do is, we need to simply iterate on our gaps array, right? And what we need to do? We need to check for its left suffix, left max and right max, right? And if the meeting time is less than or equals to maximum of left max and right max, then what we will do? We will store the, like, let's say maximum free time. What will come in this? Maximum of maximum time, comma, this G3 plus G4 plus M3. So how we will get this G3 and G4? See, let's see here, if we are at this index, if we are at this free time, then G3 will be free time of I, G4 will be free time of I, G3 will be free time of I minus 1 and this meeting time, right? So let's write here G3, G4 and meeting time only. And also we need to consider the case if this condition doesn't satisfy or satisfied, doesn't matter. We will also consider the case of the sliding. So in that case, what will happen? We will do maximum of max time, comma, G3 plus G4, because that meeting will still exist if we slide it in this. So this will remain G3 and G4. So let's see its code. So let's say if we are at this index, if we are at this gap I, then how we will get this meeting? This meeting will be I minus 1, right? Let's see. So see, in this code we have created a first free time vector in which initially we have pushed the start time of 0, because time before the starting of the first meeting is ideal time. And then we are pushing the start time of I minus n time of I minus 1. This will give the time gap between each meeting, and by the end we will push the remaining time after the last meeting. And after that we will simply create left max and right max by the method I have described earlier. And after this we will initialize the maximum free time with 0. And see here, now we have started iterating in our free time vector from the index 1, and if we are at gap 1, then our meeting will be I minus 1. So this is the meeting duration, that is end time of I minus 1 minus the start time of I minus 1. And if this total meeting duration is less than or equals to its maximum of left max and right max, so what we need to do is, we need to do G1 plus G2 plus meeting time. And if this duration, if we can't pick and place, or if we can, but we will still need to consider the case of the sliding, as we need to find the longest available free slot. So in what we will do for sliding, that is G1 plus G2, we will not calculate the meeting time because meeting will still exist in that duration. And by the end of this loop, we will simply return this maximum free time. Okay, so let's talk about its time and space complexities as well. So its time complexity we go of n, as we are iterating in this free time, as we are creating this free time, and then this left max, then right max, and then again iterating to calculate the maximum free time. So overall we are doing 4 iterations. So its time complexity will be big O of 4n or big O of n, we can say. And its space complexity will be, we have created 3 vectors, that is free time, left max and right max. So its space complexity will be big O of 3n, which corresponds to big O of n. So these are the time and space complexities for this. Yeah, this was all for this question. I hope you get it. But if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys. See you in the next video.